Well, good afternoon, everybody. Hello there. Welcome to the Academy's Morrison Planetarium and to this presentation of a tour of the universe, our last planetarium show of the day. Now, I want to find out how many of you have seen our other shows, either Living Worlds or Expedition Reef. Quite a few. Okay. This show is a little bit different. This show is completely live. And what it involves is a flight through a three-dimensional model of the universe. So we're going to have a look at where we are in the big picture of things. We're going to leave our planet far behind, leave the solar system, exit our galaxy, and fly through the galaxies to the edge of the visible universe, and then come right back by 5 o'clock, because that's closing time. But our vehicle for this trip is a piece of software that is supported by NASA, and it's actually free. It's a free download. If you like what you see on the dome during this next half hour or so, come and see me up at the control booth after the show. I'll tell you how you can get your hands on the software, okay? Now, as with all of our shows, we would like to ask that you please, during the presentation, please refrain from eating, drinking, snacking, or any kind of photography or recording. This would also be a great time to silence your personal electronics and to turn off any light-emitting devices like cell phones, cameras, tablets, those sorts of things. That light can be very distracting to people sitting around you in the dark and can actually interfere with the images that we project on the dome overhead. Since this is a live presentation, I'll be piloting us through our three-dimensional model of the universe. I promise I'm not going to go crashing into any planets or diving into any black holes, but if you find yourself feeling a little motion sensitive during the show because of the immersiveness of the planetarium experience, just close your eyes for about a minute or so, and any sensation of discomfort should go away. So I just want to mention that. At the end of the show, please exit out through the doors at the top of either stairway. If getting all the way up these stairs is going to be a problem for any of you, then just stay in your seat at the end, and our staff will assist you out the lower exits, if that's more convenient. But with that, we invite you now to settle back in your seats and make yourselves comfortable. Are you ready for a trip into outer space? Yeah, okay, well, you can do better than that. Are you ready to travel into outer space? Yeah, okay, good. That lets me know there's somebody in here. Okay, one famous astronomer once said, outer space is not that far away at all. It's only an hour's drive if cars could go straight up. So, and that's true because the officially recognized boundary of outer space is 100 kilometers above the ground. So we're going to start a little bit lower than that. We're going to start our presentation here, 1 kilometer above a place where people usually travel into outer space. We are 1 kilometer above Pad 39A at Cape Canaveral. So this is where NASA launches a lot of rockets from. SpaceX in particular launches from this particular pad. So this is 1 kilometer above the ground. You can see the pad below us, and as we rise up higher and higher, you'll be able to see a few other features. Pad 39B is just there on the upper left, and that's where NASA launched their big moon rocket from, the Space Launch System. We're traveling higher up into above Canaveral. Over on the left, you see that long strip. That's the 3-mile-long runway that the space shuttle used until 2011. And there are other launch pads down along the coast to the right, which you can see below us. And we're going to go up to about 100 kilometers. This is the officially recognized boundary of outer space. Why is that the officially recognized boundary of space? Because someone calculated back in the 1950s that at this altitude, 50 kilometers, or rather 100 kilometers up, which is about 62 miles. So roughly the distance from San Francisco to San Jose or to Santa Rosa. At this altitude, the atmosphere is so thin, it gets thinner and thinner the higher you go. Up here, it's so thin that air control surfaces like wings, rudders, flaps don't work. So up here, you have to use rockets to maneuver around. That's why this is considered the boundary of outer space. Now, it's not a hard and fast number because Earth's atmosphere expands and contracts, and sometimes it's a little bit different. But generally speaking, 100 kilometers or 62 miles is thought to be, it's considered the definition of the edge of space. However, We're going to go higher than that because people don't stop at 100 kilometers. Nowadays, when people travel off into space, they go about 4 times higher than that. 400 kilometers is about the altitude of the International Space Station. That's about 240 miles high. And it will go even farther than that, farther out to the farthest distance that humans traveled way back in the 1960s and 70s. We're going to go all the way out as far as the moon. But let's enjoy the sight of the Earth, our planet, below us as it slowly rotates around. The crew on board the International Space Station have a view something like this. They're not quite as high as we are right now, but they circle the Earth once every 90 minutes, traveling at a speed of 17,000 miles per hour. And they've got a magnificent view of our planet. But the astronauts who went to the moon between 1968 and 1972 had an even better view than that, because they got out about, they went out to 240,000 miles away from Earth, about 1,000 times farther than the space station orbits. So let's have a look at our own satellite, the moon, the farthest that humans have ever traveled. And as we do, we're going to, let's see, to find the moon, first I have to turn on the orbit of the moon so I can figure out where the moon is. And it is, let's see, it circles the Earth right about there. And I don't want to change our location or our focus too quickly. So let me just switch our center of view to the moon there. I've backed off a bit so that the change is not so jarring. But now we'll zoom back in toward the moon, toward our satellite, the nearest neighbor to Earth in space. It's a ball of rock about 2,000 miles in diameter, 240,000 miles away, 250,000 miles away. I'm also going to, let's see, I'm going to light up the entire moon so we can see the entire face of our satellite, and we'll have a look at the near side of the moon, the side that we normally can see. Now, the moon always keeps the same face toward us because it rotates around on its axis at the same rate at which it orbits the Earth. And so it always keeps the same face to us. That's why we never see the other side of the moon, the far side of the moon, as it's called. Some people mistakenly call that the dark side, but that's not the right term. It's the far side because it's the side that's farther away. But here on the surface of the moon, we can make out a lot of features on its surface. We can see the dark patches, which are called maria. That's a Latin word meaning seas, because people used to think, before telescopes, they would think that those dark patches were bodies of water. So they called them seas and oceans. The Sea of Tranquility, the Sea of Rains, the Sea of Fertility. But then on the lighter colored areas, there are lots of craters that we can see. Some of these craters are really big. The big one below us is about 60 miles across. That crater is called Copernicus. And there are a number of others. These were blasted out by the impacts of asteroids and comets during the moon's distant past. And there are lots and lots and lots of craters. You can't count the number of craters that are on the surface of the moon. And the closer you get, the more craters you see. There are mountain ranges on the moon as well. Flat areas. The maria are flat plains of dried lava. There are other very interesting features on the moon that we haven't even begun to study yet. So astronomers would love to see more exploration of our satellite in the future, and perhaps in the next couple of years, that's going to happen as NASA undertakes its Project Artemis, which is designed to send people back to the moon. And NASA says to stay and set up bases on the surface of the moon. We'll see about that. But that's our nearest neighbor in outer space, the farthest that humans have ever traveled away from Earth. But now we're going to travel even farther away, and we'll encounter distances that are so great that measuring them in terms of miles is going to be kind of silly, because the numbers are just going to get so big that measuring in miles across huge distances across the galaxy is going to be like trying to measure the length of Golden Gate Park in millimeters. The numbers just get way, way, way too big. So what we're going to do is we're going to use a term that astronomers like to use that is based on the speed of light. Now, light travels 186,000 miles per second. If you could travel as fast as light, you could travel 7 times around the world in 1 second. You could travel from the Earth to the Moon in 1.5 seconds. And you could travel between the Earth and the Sun, our nearest star, which you see over there on the left. You could travel from the Earth to the Sun, or back the other way, from the Sun to the Earth, in about 8 minutes, at the speed of light, 186,000 miles per second. So we say that the Sun is 8.5 light minutes away, the distance that light travels in 8.5 minutes. And as we look farther out into space, we'll see things that are not just light minutes away, but light hours, in some cases, light years, and even farther than that. So we're looking at an overhead view of our solar system right now. And of course, at the very center of our solar system is our star, the Sun. And the nearest planet is Mercury, about 36 million miles out from the Sun. Then comes the second planet, Venus, which is about 64 million miles out. We on the Earth, the third planet, are 93 million miles out. That, remember, 8.5 light minutes. And then next comes the planet Mars. After Mars, the nature of the planets changes. Those first 4 planets are what are called terrestrial planets, or Earth-like planets. They're small and rocky. And then there's a gap, which is filled with lots of chunks of material that's left over from the formation of our solar system. This is the asteroid belt, where there are hundreds of thousands of these chunks of material out here. But not all of those objects are limited to this zone between Mars and the next planet out. There are some that travel farther out, and others that travel farther in closer to the Sun than the Earth. And so there are lots and lots and lots of asteroids. After the asteroids come what are called the gas giants, or the Jovian planets. And the first one we encounter is the biggest planet of them all, the planet Jupiter. And that is a planet that is so big it would take 11 planets the size of Earth's positioned side by side to stretch all the way across Jupiter's face. So it's 11 times the diameter of Earth. After Jupiter comes Saturn, the planet with rings, and these 2 planets are, let's see, Jupiter at least, is visible in the sky these evenings. Just after sunset, look toward the west where the sun set, and you'll see both Jupiter and Venus, the second planet, the brightest planet in the sky. You'll see both of those planets very, very close together in the evening sky just after sunset. Saturn is not visible in the evening sky, but we've got other planets that are farther out. Saturn's about 1 billion miles out from the Sun. The next 2 planets out are Uranus and Neptune, and those planets are so far out, the light of the Sun takes hours to get to them. And let me show you one other thing out here. We'll show you the distance that the farthest spacecraft have traveled from Earth. I pointed out where the space station orbits about 240 miles above Earth, and then the moon, which is about 250,000 miles from Earth, 240,000 miles from Earth. And now we'll look at where our most distant spacecraft have traveled. These are not, they don't have people on board. These are robotic spacecraft. And this is as far as our most distant spacecraft have traveled. The farthest one going off in one direction all by itself is, that one is Pioneer 10, which was launched way back in about 1973 or so. And in going off in the other direction are Pioneers 11, Voyager 1, Voyager 2, that one's Voyager 2, it took a turn down past Neptune, and then New Horizons, the shortest path, which recently passed the planet Pluto and is now exploring what's called the Kuiper Belt. The Kuiper Belt is an area where we find the orbit of Pluto, which is filled with chunks of material, lots of asteroids, comets, and what are also called mini-planets. So this Kuiper Belt is an area way out beyond the most distant planets in our solar system, which is just filled with stuff. And there's lots and lots and lots of material out here, particularly long period, or rather short period comets. So those are things that are said in some definitions to mark the edge of our solar system, but how far out does the solar system go? Some say that it extends as far as its gravitational influence. Others say it extends about halfway to the next nearest star, to what's called the Oort cloud. There are lots of different definitions for the edge of the universe. For a lot of people, it's where the orbits of the planets end, or perhaps where the Kuiper Belt is located. But there are lots of different definitions for that. Well, let's travel even farther out now, because now we're leaving our solar system far behind. And as we do, we'll let the sun assume its normal brightness with respect to the other stars. So far, inside the solar system, we have dimmed the sun so that it didn't wash out all the planets. So we'll let the sun take its normal brightness with respect to the other stars in the sky. And as we do, we'll travel farther out now, and we'll begin to travel among the stars themselves. As we do, the constellations that we see in the sky begin to lose their shapes, because now we're traveling among the stars. We're not seeing them just from one place in space. So perspective is changing our view of the constellations. And some of these stars here are now several dozen light years away. And there's one more thing I want to show you before we get too far away from Earth, and that is actually something that has traveled farther than any human, farther than any spacecraft has traveled from Earth. It is the most distant artifact of humanity, which is our radio signals. This bubble that you see here is as far as our radio signals have traveled. We've been transmitting radio signals for about 90 years or so. Most of them, or the earliest ones, were accidental signals, but now we're deliberately sending radio signals out into space. And this is as far as our oldest radio signals have gotten, about 90 light years away from Earth. Now, notice there are some stars inside this radio bubble, inside the radio sphere. So if there's anybody there on planets orbiting around these stars just inside the radio sphere, they might have detected our radio signals. They might know about us. What would they be listening to? We don't know. But is there anybody there? Again, we don't know. If there are any civilizations on planets outside the radio sphere, where our radio signals haven't reached into space yet, they wouldn't know about us. They haven't heard our radio signals, so we're still unknown to them. But look how many stars there are. So far, astronomers say there are about 75 stars within the radio sphere that might have received our radio signals, but most of the stars that we see in the sky are way outside. But I just wanted to show you that. Our most distant footprint of humanity in the galaxy. And as we travel farther out, I'm going to leave that on so we can see where we are in the Milky Way galaxy. Up to about 100 years ago, astronomers thought that the Milky Way was the only galaxy in the entire universe. They didn't think there were other galaxies in space. But Edwin Hubble, about 100 years ago, gave evidence that there are other galaxies far outside the boundaries of the Milky Way. Not only that, he showed that those other galaxies are moving farther and farther apart from each other. So not only was the universe bigger than we thought, but it's getting even bigger still. This is where we are in the Milky Way, which is a huge flat disk of several hundred billion stars. We are nowhere near the center of the galaxy. We're out about 2/3 of the way from the center, out along one of the edges of one of the spiral arms. As you could see earlier, the Milky Way is a disk. It's very flat. So even though it's so wide that a beam of light would take 100,000 years to cross from one edge all the way across to the other, it's still very, very thin. And many galaxies are like this, very thin, disc-shaped spiral galaxies. They've got arms of stars winding out from the center, sort of like pinwheels in space. So, the Milky Way is not the only galaxy in space. In fact, it's a member of a small cluster of galaxies called the Local Group. Now, the Local Group contains a couple of dozen galaxies, including the next largest galaxy to us, the Andromeda Galaxy, which is almost a twin of the Milky Way. But as we travel farther and farther out into space, leaving the Local Group behind, we see other objects up here. which, all these different colored spots you see on our dome are not stars, they're actually whole galaxies. This is the result of many, many surveys of the universe that have been taken over the years. And so these are the locations, all based on actual survey data, of other galaxies in space. And you can see that many galaxies are grouped together, forming what are called superclusters, like this one right here over to the left, a huge cluster of thousands of galaxies, another one over on the right. And there are many, many, many of these superclusters of galaxies, which are separated by large empty spaces or voids. But the galaxies are distributed into these clusters and filaments that give the universe a very interesting texture, almost a foamy or sudsy texture. And if we travel farther and farther out, if we travel far enough out, we see that our model of the universe, based on all the surveys that we have taken of all the galaxies in the sky, our model of the universe right now looks like this. Now, that's a very interesting shape. Does the universe really look like a big butterfly? Our model does. But what this means, what this tells us, is that our survey of the sky is incomplete. We're not seeing everything, because you see these two big fans going off to the right and off to the left, and a big empty space between them. But that empty space is not really empty space. It's actually parts of the universe that we can't see very well because there's something in the way, blocking our view. What's in our way is our own Milky Way, the dust and gas in the plane of the Milky Way that is preventing us from seeing out into these areas. And that's why it looks like there's a big gap between those huge cones of galaxies fanning off on either side. But eventually, as our techniques and technologies get better, we do expect to get better views of what's there in that area. We do expect to see more and more galaxies and even out our map of the universe and see more galaxies in all directions. But if we travel far enough out, we'll see the most distant objects that have yet been detected by astronomers. These objects are so bright that at the tremendous distances at which they're located, they must be very, very energetic. These are things that are called quasi-stellar radio sources, or quasars for short. And quasars, generally speaking, are out about 10 billion light years away from Earth. So at the edges of the cones, you see those orange dots there. That's a survey that mapped out the quasars that we see all around us. Those are objects out around 10 billion light years away. And these are believed to be the centers of very young newborn galaxies that are powered by supermassive black holes, which are very energetic. And we're only beginning to understand supermassive black holes. And even farther out than that, in fact, permeating the entire universe, beyond everything that we can see, is a faint radiation coming from all directions, called the cosmic microwave background. This is a faint radio hiss that surrounds everything, permeates the entire universe, and is said by astronomers to be the best evidence of when the universe began expanding. Remember, I said Edwin Hubble showed that the galaxies are all moving apart from each other. And at some point, that expansion must have started somewhere. Astronomers think it began about 13.8 billion years ago, when the universe was very, very hot, very compact, very dense, and very opaque. So opaque that light could not travel from one place to another. But then suddenly the universe began to expand. It became very transparent. It became cooler. It became thinner, more rarefied, and light could finally be able to travel from one place to another. And this mottled background that we see is that first light, which began to shine and travel through the universe about 380,000 years after the expansion began. So that is astronomers, what they say is the best evidence for what they call the Big Bang, the beginning of that expansion. Not really the best term for it, but that's something from about 13 billion years ago, the first light in the entire universe. And that's as far as we can see. It is the edge of the visible universe. And that being the case, the only place we can go is back in toward the center. And as we do, it may seem, if you look at our model, if you look at our map, it looks like we've placed ourselves at the very center of the universe. Is that really the case? Are we the center of the universe? I know some people who think they are, but that's not really true. We're not at the center of the universe. It's just a matter of perspective. It's a result of the fact that we're the ones who made the map. So it looks from our point of view like everything is surrounding us, but if there were somebody at some other point in the universe making their own model of the universe, it would look similar. They would place them at the center, but that's just a matter of their point of view. We've seen now so many galaxies containing so many hundreds of billions of stars. There must be lots and lots of planets out there as well. I mean, a lot of astronomers say that it's probably very certain that almost all stars have planets orbiting around them. And since 1994, astronomers have discovered more than 5,000 other planets orbiting distant stars. These are called extrasolar planets, or exoplanets for short. So with so many galaxies containing so many stars, each one orbited by so many planets, what are the chances that there are planets out there like Earth itself? The number of extrasolar planets we're discovering keeps growing day by day. So how many of those planets are like our own Earth? We don't know. We don't even know if there are any that are like the Earth, because it takes a lot of things, a lot of conditions to be fulfilled for a planet to be like Earth, to have life on its surface. It's got to orbit the right kind of star that gives off a safe type of radiation. It can't be too close to the star, so it's not too hot. It can't be too far away so that it's too cold. The planet itself has to be the right kind of planet. We think it needs a rocky surface like Earth so that life has a place to evolve. And at the same time, there are other conditions. It's got to have the right kind of materials. It has to have the right kind of minerals and elements to provide the nutrients that will support life. So we haven't found any other planets that are like Earth yet, but we're still just scratching the surface so far. We're only beginning to discover other planets out there. And so in all of our travels out to the edge of the visible universe, past all these planets and stars and galaxies and superclusters of galaxies out to the edge of the visible universe, with everything that we've seen so far, as we approach our home solar system, we find that there is quite literally no place like home, at least not as far as we know just yet. Our planet Earth is the one place in the solar system that has life upon its surface and fulfills all the conditions that are necessary for life to exist. So as we approach our home planet, let me welcome you back home to the Earth, a very special, fragile planet that we need to take good care of so that it can continue to support the life upon its own surface. And with that, that concludes our tour of the universe. Thank you all very much, and we hope you have a very pleasant evening.